Right now, at this very moment, a moon orbiting Saturn is shooting a geyser of water into space. A geyser so massive it stretches over 6,000 miles. That's roughly the distance from Los Angeles to Buenos Aires. Inside that water, scientists have now confirmed the presence of hydrogen cyanide, the very molecule most theories say kick-started life on Earth. And here's the part that stops researchers cold. The energy powering that ocean isn't just keeping the water liquid. It's generating the equivalent output of over 66 million solar panels. Something extraordinary is happening inside Enceladus. So, let's start with the basics, because this moon doesn't get nearly enough attention. Enceladus orbits Saturn about 148,000 miles from the planet's surface. To put that in perspective, you could fit this entire moon comfortably inside the borders of Arizona. It's small, it's frozen, and at first glance, it looks completely dead. The surface temperature sits at around -330 degrees Fahrenheit. The whole thing is wrapped in a shell of ice so reflective, it bounces back nearly 100% of the sunlight that hits it. When NASA's Cassini spacecraft arrived at Saturn back in 2004, scientists honestly expected Enceladus to be a frozen wasteland, nothing more than a cold rock drifting through space. They were wrong. Cassini's instruments picked up something that made no sense. Saturn's powerful magnetic field was bending and bowing around this tiny moon in a way that defied the math. Something was physically pushing back. So mission controllers made a bold call and redirected Cassini for a closer look. What they found didn't just surprise them. It rewrote the entire conversation about where life might exist in our solar system. Near Enceladus' south pole, Cassini photographed 4 massive parallel cracks carved deep into the ice. Scientists named them the Tiger Stripes, officially designated Alexandria, Cairo, Baghdad, and Damascus. From these cracks, Enceladus was firing towering geysers of water vapor, ice particles, and gas hundreds of miles into space at over 800 miles per hour. The eruption is so powerful and so continuous that the moon's own gravity can't hold on to the material. That ejected ice shoots out and actually forms Saturn's outermost ring, called the E-ring. Enceladus is literally paving its own orbit with frozen ocean water. Now, if water is blasting out of a frozen moon at those speeds, there's only one explanation. There's a liquid ocean trapped beneath that ice crust, and not a small one. Gravity and density measurements suggest this ocean is roughly 6 miles deep, almost as deep as the Mariana Trench here on Earth. But here's what's wild. The ocean doesn't just sit under the South Pole. Scientists confirmed it wraps around the entire rocky core of the moon. It's a global ocean, completely hidden beneath the ice. So the next obvious question is, what's keeping it from freezing solid? The sun is nearly 900 million miles away from Enceladus, so solar energy isn't the answer. The answer is gravity, specifically a gravitational tug-of-war. Enceladus shares its orbit with a neighboring moon called Dione. For every one orbit Dione completes around Saturn, Enceladus completes exactly 2. Every time these moons pass each other, Dione's gravity gives Enceladus a slight pull. This forces Enceladus into an oval-shaped orbit around Saturn. Because that orbit is oval, Enceladus constantly moves closer to and farther from Saturn. When it gets closer, Saturn's immense gravity stretches the moon. When it moves away, the moon relaxes. This relentless squeezing and stretching creates friction deep inside the rocky core, and that friction generates massive amounts of heat. Scientists call this tidal heating. It acts like a furnace buried inside the moon, melting the ice from the bottom up and maintaining that liquid ocean in the darkest corner of our solar system. Here's where things get serious. Astrobiologists use a specific checklist when they're evaluating whether a world could support life. It's an acronym called SHNOPS: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These are the 6 essential building blocks of all known life on Earth. During its flybys, Cassini flew directly through Enceladus's plumes and physically sampled the water. Early passes detected carbon, hydrogen, nitrogen, and oxygen. 4 out of 6. Impressive, but not complete. Then in 2023, a research team analyzing data from Cassini's Cosmic Dust Analyzer published a landmark paper. By carefully studying ice grains that had escaped Enceladus and formed the E-ring, they found clear signatures of phosphorus dissolved in the Moon's ocean at concentrations hundreds of times higher than in Earth's oceans. That left only sulfur. And while direct confirmation of sulfur remains an active area of research, scientists have identified sulfur-bearing compounds in related data that strongly suggest its presence. All 6 building blocks of life, potentially present in a single ocean, on a moon orbiting Saturn. But having the ingredients doesn't mean the kitchen is open. You also need energy to cook with. In December 2023, a team led by doctoral researcher Jonah Peter at Harvard University published findings that genuinely stunned the scientific community. Using detailed statistical analysis of Cassini's ion and neutral mass spectrometer data, they confirmed the presence of hydrogen cyanide in Enceladus's plumes. This is significant because hydrogen cyanide is considered the starting point for most scientific theories on the origin of life. It's the molecule that can be stacked and combined in multiple ways to form amino acids, the building blocks of proteins, and ultimately, living cells. But the team didn't stop there. They also found an array of oxidized organic compounds, complex molecules that, on Earth, serve as fuel for living organisms. The lead researcher described the difference in energy potential this way. If the previously known chemistry on Enceladus was like a small watch battery, these new findings suggest the ocean might be more like a car battery, capable of powering far more complex biological activity. And in late 2025, a separate team reanalyzing Cassini's fastest plume flyby, just 65 feet above the surface, found clear evidence of esters and ethers. These fragile molecules break down quickly in space. The fact that Cassini caught them means they were synthesized deep inside the ocean and ejected just minutes before the spacecraft flew through. The hydrothermal vents are active right now. For years, scientists assumed most of Enceladus's heat was escaping from the active South Pole, where the geysers are. The North Pole was considered cold and quiet. A 2025 study led by Dr. Georgina Miles from the University of Oxford changed that assumption entirely. Her team went back through Cassini's infrared observations of Enceladus's North Pole, comparing data from the Moon's winter in 2005 to its summer in 2015. What they found was that the North Pole was running about 7 degrees Fahrenheit, warmer than their models predicted. Heat was leaking out from the ocean below. The measured heat flow came in at about 46 milliwatts per square meter. Across the entire Moon, that adds up to a total heat output of roughly 54 gigawatts, which matches almost exactly with the amount of heat generated by tidal squeezing and stretching. That balance matters enormously. It means Enceladus isn't losing more heat than it's generating. The ocean isn't slowly freezing, it's stable. And a stable ocean means life has had time to develop, potentially a very long time. Here's the honest truth about where we stand. Cassini was an extraordinary spacecraft, but it was built to be a weather and geology satellite. not a biology lab. Its instruments could weigh molecules and measure magnetic fields, but they couldn't detect a living cell or sequence alien DNA. As one researcher put it, Cassini was searching for the smoke, not the fire. We now have a beautifully detailed picture of an ocean that checks nearly every box for habitability. Liquid water, a reliable heat source, a rocky seafloor producing hydrogen gas, complex organic chemistry, the building blocks of life at extraordinary concentrations. What we don't yet have is a mission designed to actually look for life. The European Space Agency has a mission in planning that could reach Saturn's system as early as 2053, with a potential landing on Enceladus in 2058. And a privately funded concept called Breakthrough Enceladus has proposed sending a probe specifically designed to search for biosignatures in the plumes. Think about what we've actually established here. A moon the size of Arizona, nearly 900 million miles from the sun, is harboring a global saltwater ocean. That ocean contains every known building block of life. It has a confirmed energy source powerful enough to fuel biological metabolism. It has active hydrothermal vents, the same type of environment where many scientists believe life first emerged on Earth. And it's been stable long enough for life to potentially take hold. We haven't found life on Enceladus, but we have found everything life needs to exist. The question is no longer whether Enceladus could support life. The question is whether we're ready to go look. If this video made you think, do 3 things right now. Hit subscribe so you don't miss what's coming next. Drop a comment below and tell us, do you think we'll find life on Enceladus in your lifetime? And share this video with someone who loves space, because this is the kind of discovery that deserves more than one conversation.